For part H, we have a to the fifth, and that whole thing is taken to the third power. This is an example of the power rule. And the power rule says if you have a to a power, and that whole expression is to another power, you're going to multiply the exponents. So this is going to be a to the 5 times 3 power. 5 times 3 is 15. So this is a to the 15th power. Now that we have that, we're ready to then see what happens if we have something a little bit more exciting. So for part A, let's go ahead and say that we have 4x to the third, y to the second, all to the third power. So the first thing to note is that the 4 is connected to the x third by multiplication. The x to the third and the y squared are connected by multiplication. So this is going to be a product inside the set of parentheses. So we have a product to a power. Product to a power is another one of our rules. And the product to the power rule says that we can bring that power of 3 down to each and every one of these factors. Now, a lot of people, when they do this problem, they'll bring that power of 3 down to part of the problem, but not all of it. So count out the number of factors. There are, in fact, 3 different pieces that are connected here by multiplication. So each one of those factors has to get its own copy of the 3. So we're going to bring that power of 3 down to our first factor of 4, and then we're going to take the 3 and bring it down to our second factor of x to the third, and we're going to bring that power 3 down to our third factor of y squared. Now that we have this then, one part is simply a number problem. 4 to the third power, we take 4 times 4 times 4, that's going to be 64. And then we have x to a power, and that whole thing is to another power. So this is another example of the power rule. We're going to multiply the 3's together. 3 times 3 is going to be 9. We're going to get x to the 9th. And then we have y to the second to the third. That again is an example of the power rule. So y to a power, 2 times 3 is going to give us 6. So we have y to the 6th. So as I said a moment ago, one of the most common mistakes that people make is that they forget to bring the power of 3 down to the number 4. So remember, the 4 gets its copy of the 3 as well. You have to have that 64 out in front. Well, let's go ahead and check out what happens if instead of a multiplication on the inside, we have a division. So let's check out part J. So for part J, we have x divided by 3 to the second power. Well, x divided by 3 to the second power, this is an example of a quotient. So we have the power of a quotient. Power of a quotient rule says we can bring that power of 2 down to each one of these items, to the numerator and to the denominator. So we're going to have x to the second divided by 3 to the second. But once again, 3 to the second power, we can actually do a calculation there. So it's part of the problem to do that calculation. 3 times 3 is 9. So we're going to have x to the second divided by 9 as our final answer. Now let's try one last problem for the day. Here is k. We have negative 4x squared divided by 5, and that whole expression is going to be squared. So this is going to be an example of the expanded power rule. And once again, it's always a good idea to double check. Everybody inside the set of parentheses is connected by multiplication or division. And because of that, it is an example of the expanded power rule. So just like we saw in these problems up above, I can bring that power of 2 down to every single one of the pieces inside that set of parentheses. So we have that negative 4. It's going to get its own copy of that too. We have the x squared. It's going to get its copy of that too. And in the denominator, the 5 is also going to get its copy of the 2. Now, notice something that I did here with this negative 4. The base was negative 4, so I put the negative 4 inside of a set of parentheses. And then I put the square on the outside of that set of parentheses. Whenever you're doing these exponent rules, you have to be kind of careful about who is the base and where is that negative going to go. So in this case, we have negative 4 squared. Well, let's go off to the side and talk about that for a sec. If I have negative 4 quantity squared, that's going to be negative 4 times negative 4. And that means we have a negative times a negative. Negative times a negative is going to be a positive. So that's going to be a positive 16. So we have 16, and then we have x to a power, and that whole thing is to another power. Once again, that's an example of the power rule. So we're going to multiply those. 2 times 2 is 4. So we have x to the 4th. And in the denominator, once again, it's just a number problem. 5 squared, 5 times 5 is going to be 25. So we end up getting 16x to the 4th divided by 25. At this point, you are ready to move on. You can go ahead and start by practicing using worksheet 26. And then once you're done with worksheet 26, you can go out and do the online homework 26, and you'll then have a chance to do the written homework 26 as well. Have fun.